What is up? We're gonna do a lab intro video. People have requested that. They want to know, what's up with Energetics Labs? How do you do? What kind of crazy shenanigans you got going on here in the Energetics Lab? I'm just gonna go over how I do it. There's a lot of different ways to do this. This will hopefully save you a lot of time. Now, when I say lab, I mean, I'm talking, lab, right? Because this is just a shack. Now, I'll tell you the first shortcut in energetics research if you want to get into being an amateur energetics enthusiast, technician, researcher, whatever. So the very first shortcut is that all of your theories, no one gives a flying
care
about your theories. Your theories mean nothing. So if you don't have measurements or results, your assertions or your theories, they mean nothing at all. They are simply, wisps of nothingness that float through everyone that's involved in this field's head all day, every day, all the time. So what I'm trying to say is that, you want to be testing. So if you are testing things, if you're conducting tests and keeping record and recording, then those tests are worth more than a million, little guesses of, what shoulda, coulda, woulda happened. If you just test something and just record what happens and just show it or demonstrate it, that's all the value in the world. This is a pile of
notebooks
that is in my lab. This is just, I don't even know what kind of, what is this? I have boron carbide energetic time delay composition, dinitromethyl substituted azoles. This is just like one pile of many piles of unused material that, it's a waste. It's a waste of paper. It's a waste of binders. I have to unfuck this binder, take all the pieces out and reuse them, which I do, but I've got a lot of binders. So it's not just one pile like this. I have lots of piles like this. This is the messiest. Most of them, it's like on an army cot. Most of them are, on bookshelves. But this is just, some project that, got away from me. So in terms of your aim of how you research, I guess the lesson here is that you don't want to you want to pull back from theorizing, you want to pull back from what seems romantic to you in the broad scheme, because it'll become overwhelming. You'll pick too many topics. You'll never have enough time to research the things that you want to research. You have to be selective. You need to use Pareto's principle of 80-20. You need to pick the thing that you need the most and go after it, and not be distracted by side interests in the order of precedence in terms of your research. You want to keep record, right? Because you don't want to do things twice. If you don't keep record, you're going to be doing a lot of
efforts,
like 3 or 4 times before you realize, I've done this 3 or 4 times. So here's an example of a current lab book. So this is like a rolling, lab book. So it changes all the time. So inside the lab book, I use page protectors, obviously, right? 3-ring binder, page protectors. Obviously, the metal's all oxidized to
iron oxide
because of NOx. And then we've got page protectors to protect from liquid spills, various liquids that would smudge the ink, making it difficult to ascertain what the
writing
is going on here. I will use tags on the general topic of what is the thing that I'm doing in here, and then I will shove a ton of stuff. Like this is HNO3, right? So that means this is like nitric acid runs. So this is just records on previous nitric acid runs. Maybe I'll have some tables, something relevant like that. Nitroguanidine, this has like old nitroguanidine synthesis, like the last one that I did in 2023. Haven't made nitroguanidine in a while. When you get into something more active like NAP, you're going to have lots of notes of, tests that you've done, small notepads, things like that. You can just shove them in here at the end of the day, right? Like, so you're taking notes on stuff. You've got notepads all over the place. That's okay. Don't get dead set on having one format of paper. You just grab whatever you can. If it's a napkin, it's a napkin. This system of using, a waterproof page protector, you can just shove the stuff in there like a pocket, and now it's just stored away. You decide what is important enough to keep or to discard, and discard you must do. And I have all kinds of
paper
that I've thrown away that are, various lab notes of different things that are not worth keeping. typically my format is that at the top, you want to have the date. And the reason that you want to have the date is because some of the
record,
you'll work on it so many times, like H&O3 production, you're going to want to keep dates because you're going to have so many notes over the years that if you don't keep dates, you're not going to, you don't really care about your notes from like 5 years ago. You care about your notes from the last few times that you worked on something, right? Because it's going to be the most efficient. You'll have learned the most information about the topic. It's the first thing that you'll look for in terms of making sense of what's what. So for literature reference, right, you're going to want to pick a topic, and then you're going to want to read all the published literature on it. So there used to be ZLive was a big thing that's been shut down by the feds. So now you've got like Sci-Hub. You can get creative on finding literature. It's out there. Urbanski is a huge one. Urbanski and Patter are huge. 2700, Patter 2700. Anything common you're going to find in there. You're going to find a lot of eclectic information on explosives in there. So it's a great place to look. So what you do is you do your research on a topic. You pull your documents that you want to reference. You pull those down. You come up with a plan on what you're wanting to execute. I want to recreate a synthesis, whatever. You're going to do that between what you print off or copy down from these publications into your book, right? And then you just start testing, right? So to start testing, you don't need to know
very much.
You don't need to know anything about a material. The trick is that you wanna start small, so you don't BTFU yourself and kill yourself. You want to use small quantities because when they blow up, it's less violent and puts off less energy. So always go small. So you should be, like primary explosives, you should never exceed 5 grams, in my opinion. A secondary explosive, especially when you're figuring one out, especially if it's experimental, you really want to work in the gram range. Over here on the wall, I've got a bunch of
molecular weights
that I wrote. This is just, random
molecular weights
that I needed to know at one point or another, and wrote it in there. And I've got another one over here, and a bunch of dots on that. Okay, before we get any further, let's talk about the most important piece of lab equipment that I have. You could have never argued to me that this would be useful, and I wouldn't believe you if you said it. A pump spray bottle, a pump spray bottle where you can pump air in, and then you can, spray it. This is the most useful thing for cleaning out beakers, for cleaning surfaces on counters, wiping things down. I mean, I use this all the time. So you're probably going to have a bunch of chemicals, right? Because you're going to be doing
work
with chemicals. You need a way to store them. I'm like running out of good ideas here. So I've got some chemicals on the ground in buckets. That's pretty common. You're going to run into that. So this first cabinet, I opt for my oxidizers on top and my fuels below that. I don't really know what the logic is behind that. You had to pick one of the lesser evils of is the oxidizer going to drop onto the fuel or the fuel on the oxidizer? I don't know. I picked the oxidizer up top. I don't know if that's retarded or not. I keep all my
chemicals
in here. So, you got lots of different types of various oxidizers. That's a Teflon powder. Just lots of different oxidizers in here. We got some fuels in here. Some of these are metal fuels. They're like carbonates, sulfur. There's some hydrazine in here, cyanoguanidine, cyanuric acid. Below that, I've got a lot of acids down here, liquid acids. I've got formic acid and phosphoric acid. I've got some liquid glyoxal that I keep down there. It's lower to the ground so that the stuff doesn't break, right? Because a lot of these bottles are going to be glass and they'll break, so I want to keep them low to the ground, keep it less chance of breaking. These are just empty bottles down here. This is just a bunch of random crap. That's what is that? That's CS gas powder. Nitrates, of course, you're going to have a lot of nitrates, so you're going to have those sitting around. The usual stuff that you're using is going to be all over the place. You're just going to have it everywhere. Buckets and buckets of oxidizer, just there's people that have tons of ammonium nitrate that are, they use for interjects. Then I've got a box over here of metal fuels. Apparently I've got some metal oxidizers in there also, which, it's not really hazardous, because you're not going to set off a thermite reaction on accident here, unless something goes really wrong. But most of this is metal fuels. that are going to be in here. This is just like an old demo box from the Army, and then I fill it up with metal fuels, that I would commonly work on. So you're going to have a lot of acids that are saved up. So, what is this? These are just like some totes. I use some totes. I fill these totes up with, what's in here? I'm guessing it's sulfuric acid. So these totes are just filled with sulfuric acid drain cleaner. Here's some sulfuric acid I put in giant jugs. Sulfuric acid, lined on a shelf. I really like these totes because if you spill sulfuric inside, like some of these bottles leak. So I like to use these containers. They really hold sulfuric acid spills pretty well. Pretty much how you want to organize things is by fuel and oxidizer in terms of separation. Right? You want to keep your fuels and oxidizers separate. This is all amino acids. A big amino acid research guy. I love it. I mean, it's kind of useless, but it's not useless. There's lots of cool stuff with amino acids, but there's a lot more useless stuff with amino acids than there is useful. So that's why I say that. Outdoor rated freezer, right? Open top freezer, chest freezer. This is what you want to use. They're the most efficient. You don't want to use open door freezers or refrigerators. You can actually run these as refrigerators if you want. Lots of materials that get really hot during nitration in here. I also keep nitric acid. I keep my industrial nitric acid. I keep high test nitric acid down here. I got some sulfuric acid in there. I keep my amino guanidine in here pretty much all the time for my caps. It's always up front. Amino guanidine, I think it actually goes through some decomposition on its own when it's not complexed. If you have really high temperatures, so if you get like 90 degrees Fahrenheit for all day like it does here in July, then you'll have some decomposition. So I keep it cold, and that prevents that. It helps to preserve the amino guanidine. I got here, what is it? Penerythritol. I just put it in this weird funky brown 1970s bottle. If you're new to explosives, you should understand that the Germans invented all of the explosives. All of them. Okay, here's something interesting over here. So, I have a lot of vacuum pumps. So here's some traditional rotary vacuum pumps. I don't know if you can see that in there. This is like an old Welch. They're great. They're fantastic. I've got another one over here. I've got lots of these. I never use these at all. You know what I use for Intergex research? I use a hand pump almost all the time. This is what I use almost all the time for vacuum applications. For filtration, this is what I'm using all the time, a hand pump. There's a little bit of amino nitroguanidine nitrate. So I guess what is the first thing that you're going to use when you start producing? It's mostly going to be nitrate esters and nitramines, things like that. That's typical secondary explosives. So you're going to have a lab stand, right? Usually 3/8 or 1/2-inch rods. A thermometer holder is very handy. You don't need one. You can use a clothespin with zip ties or something like that. The actual holders are pretty nice. They really hold the thermometer pretty well. So the clamps hold whatever vessel you're going to make stuff in. And then, you're going to need your method of heating and mixing, because you're going to have temperature control. You're going to have a way to stir. So you have the hot plate solution. Now these hot plates, I typically buy used hot plates off of eBay. That's pretty much what I do all the time. I blow through these things. These are hot plates with magnetic stirring in them. So you use magnetic stirrers. They're kind of a crapshoot. You got to look around and find which PTFE magnetic stirrers work the best. Some of them are really ineffective and weak. Some of them are really strong. It just depends on what you get. I will tell you that the most, like the biggest game changer in terms of production of nitrate esters and nitramines is an overhead stirrer. So this is an overhead stirrer. This one is a Cole Parmer. And I got this used off eBay. It was fairly inexpensive. Most of these I buy less than $100. And then I fit it with a coupler that I find on eBay to match this shaft with the commonly available PTFE shafts that that you can find on eBay. So these PTFE shafts, you can use these in nitric acid. PTFE is totally chemically resilient, and it's not going to react with hardly anything at all. So this is the material that you want to use with nitrations. It's not going to corrode. You can leave them dirty for years, and it's not going to make any difference at all. Here's another overhead stirrer unit. This one's a cheaper. It's very robust. This is it's a high RPM overhead stirrer, so I don't use it very much. You can chuck there. You can chuck right here. I mean, they both will spin. This is your speed controller right here. These are just various overhead stirrers, but an overhead stirrer can it can really up your game in terms of your output pace. For energetics, you can get a lot more material out the door using overhead stirring than you can with magnetic stirring. I do a lot of stuff that's just open air. Outside, outdoors, I think it's underrated. If you're outdoors, you're not going to poison yourself. You're not going to injure yourself with NOx. Those gases are no joke. You don't want to breathe them ever. I do a lot of open nitrations with lots of ventilation or outdoors. I really like this Marienfeld glass. It's made in Germany. It's really good. You can find it on eBay. It's super cheap. I'd say 90% of my nitrations are open vessel, not gas controlled. I'm not scrubbing gas. I'm just doing them outdoors, or for videos, I'll do them. A lot of times I'll do them indoors on a tabletop and then just vent with a large fan. I'll vent outdoors. This is a Mega Power, super blower fan here. This is a direct drive fan that it's extremely powerful. So you've got to have your place that you're going to do reactions with venting. Where are you going to vent all the gas? You're going to vent it out of the door, you're going to vent it out a window. Are you going to be a fancy pants guy and have a fume hood? I don't know what you're going to do. Then you're going to have it made. And then once you have it made, the next thing that you're going to have to do is filter. So I think that the way the lab should be divided up is a production station and then a filter station. So this is my filter station. So down below here, you'll have a lot of solvents down here. We've got acetone, nitromethane. We've got some ammonia. We've got some isopropyl alcohol over there. Then I come up here and I've got another hot plate magnetic stirrer. This would be used for separations or, non-priority reactions, something really mild. I would do it over here. And then I've got my filtration. I'm using a 2-liter takeoff filter flask for most applications. Small applications, it works great. I've got these plastic filter funnels, and these are just awesome. They're 2-piece, so this section right here pops off. I'm not gonna do it. It pops off. I've got an adapter to make up the difference in diameter here to make this vacuum tight, and then I just connect with some vinyl tubing. I connect my hand pump, and this is my setup. Of course, we're using coffee filters, right? Coffee filters from the store, white coffee filters, not brown. White coffee filters, those work great. Another thing that works really well is your polypropylene flasks and jugs, because these are chemically resistant to a lot of extreme chemicals. So you don't always have to have stuff going on in glass. A lot of times you can use plastics that won't put off fragmentation. Over here we've got blenders. I've got multiple blenders sitting around all the time. These blenders right here, these are oxidizer blenders. So I've got some fuel blenders that I use in a different area, and these are oxidizers. So this one's not marked, but this one is an oxidizer. I've got another blender over here. This one's clearly marked oxidizer, so I don't mix it up. And you couldn't spread off. Look at that. All that material. And, that's important, because if you were blending, cross-contamination between a fuel and an oxidizer and blending at a high RPM, you could probably get a detonation. On the filtration station, I've got a heat source. This is for heating solvents for dissolving materials. I've got over here, this is actually on. Let's turn it off. This is my hot plate. This is a big star on the filtration station. So this is filtration and drying. Right here, this is a Pyrex pan. It just fits right in here. You control your temperature here. Flip this on. That is the actual name of it. A Model 135 flotation bath from Fisher Scientific. And these are just freaking awesome, man. I use this all the time for all kinds of I dry out 99% of my energetics this way. This is a piece of refrigerator glass. Okay, I got a piece of refrigerator glass. I took this out of the trash. I use this anytime that I want to, block heat loss and keep heat inside of there, like milk casting, something like that. I'll use the refrigerator glass to do that. So when you get done with your production, your filtration, separation, recrystallization, once you get done with that, you're going to go into storage. So most of the stuff that I'm doing is like I'm doing testing and analyzing of materials. So I'm using small containers, 1.5 milliliter containers. This one's an old RDX container. These are all bottles used for previous ETN tests. Obviously, it shouldn't have to be said, but let's say it anyway. You can die in this field. So this field is not for everybody. This is not something that everybody on the internet should do. People die, not often, but it does happen from, accidental discharges, poisons, fires. They poison themselves. They have a fire in the lab, something like that. So it's a hazardous field. People blast around here all the time. So we don't have any trouble. Everybody knows the cops know the people. We don't have any trouble with blasting. People are blasting dynamite, ammonium nitrate out here all day, all the time. It could be any day they're doing blasting. This building has no one living above it. There's no one living above it. There's no one living outside. There's nothing but grass. If we had poison gas release in here, fires break out, unexpected explosions, all that stuff isn't going to harm anybody at all because there's nobody around. Right. So that's in stark contrast to you if you live in one of these, golem, godforsaken cities where you're packed in like sardines and have no rights. It's going to be a totally different story. I'm not even going to get into the legal side of it in terms of explosives. I'm not going to touch that at all. That's entirely on you. I don't care. I'm not going to do it. You can figure it out. So once you have your explosives, finished, stored, you're ready to, go ahead and start using them. You're going to have to process them. That means you're going to have to be loading them into charges and initiating devices or charges. You're going to need a station for that. So this is kind of my, table that I use for loading devices and, or I shouldn't say devices. I'm not going to say that. Loading charges and, initiation, caps, doing caps, all that. I do all that stuff right here. So it's just a black top. This is also where I film most of the videos. When you see a substance getting sorted out in a video on a black background, this is usually where I'm doing it for, handling and loading explosive. So things to note about this station is that there are no explosives stored right here. There are no fuels like alcohols or solvents or anything like that right here. I don't want things catching on fire. I don't want things exploding, accidentally and causing massive detonations because I wasn't thinking about what I was doing. And to control that, to cause that, I just keep things separate. I don't bring that stuff over here. I always, I'll load a cap on my weighing station with my, my setup, and then I'll remove the primary explosive. I don't keep things over here. Just whatever you're going to work with, you work with it and then you put it away. Of course, under the table I've got stuff for equipment for firing. So this is loading, priming equipment, firing equipment. This is a present current generation firing device that I use. There's some things that you can do in improvised ways for booby traps and things like that with 9 bolts that you can't do with other cell forms, and so I always use that greater creative potential there. Anyways, so if you'll notice, this is extremely inexpensive. So this is a switch. I like to make my stuff universal and reproducible so that I can make it on site somewhere else. Like if I go somewhere and I don't have the equipment to make a firing device, I can always rig something up. So anyway, so I'm using a light switch, residential light switch, standard 120 volts, 15 amp light switch. So I'm going to run 9 volts of power into the light switch with the load wire, being terminated by the gate on the switch. So, you know, the signal, the load signal that's going to the light is then passing through this momentary on switch that's normally open. From there, it goes into, you probably can't see it, but inside of here, you know, I've just soldered in a buck converter. So this is a buck converter with capacitors and all kinds of little doohickeys. It's a circuit board. So these are very inexpensive. This is a voltage converter that steps up from 9 volts. You can control the output to an extent. I've got this one set at 40 volts. So what this does is it takes the signal out of this momentary switch that goes into here, into here rather, and then it pumps up the volume, you know, on your voltage to 40 volts, and then you get a 40 volt output. So 40 volts is, you know, quite a bit. I mean, you can set off E-matches, right? You can set these off with, you know, it's like 280 milliamps of signal, and you know, it's like a 9 volt battery. You can just touch it on a length of wire and it shoots great. I generally use RG174 and 22 AWG. That's what I've been using more recently is 22 AWG. The RG174 coax, obviously you can get the quick disconnect BNC connectors, right? So if you're doing quick disconnect BNC connectors, I mean, this is very sexy for hooking up a charge. It's a single line. You just connect lines or connect charges. I mean, you can put the mating in onto a charge, you know, and then just hook this up. Really very sexy, very quick. The other one that I use is going to be, you know, 22 AWG is very, you know, it's pretty inexpensive, and you know, there's not a lot of physical resistance in this wire, so you can really roll this stuff up and get a huge amount that you can carry. It's not too much weight. So this is what I really go with. So in the detonator video, I said, I was talking about the resistance being less or lower for the wire. I was being retarded and drunk because what I'm talking about is the, you know, like how stiff this is very usable. So this is reelable. You can run this in a reel, you can wind it out, pay out, and you can carry a ton of it. I was talking to an engineer the other day and he was telling me about the minimum distances, firing distances for a 9 volt battery. I don't remember exactly what that was, but you know, I mean, normal runs, you know, 100 feet or something for test blasts, that's no problem on a 9 volt. You can certainly get farther than that. When we're using the 40 volt stepped up signal, that's where the magic really happens, because you're going to be able to push through 22 AWG. You're going to be pushed through something like, with a safe margin of error, you're going to be able to get, you know, 2 kilometers off of, you know, a 40 volt signal through 22 AWG, which is great. It's a very flexible system. You know, I keep lots of, you know, electronic equipment, motors, stuff like that. I mean, they just keep crap. I've just got crap all over the place from equipment that I take apart. That affords me cool stuff like, you know, for instance, like this really excellent spring-loaded heavy-duty button. It's a 600 volt button. Of course, we're not using that. We're using a 9 volt signal. So it's going from the 9 volt into this light switch. It's going through the light switch into this momentary on switch. This is a dual, so you can you know, wire this up for either normally closed or normally open. So I've got it for normally open. So what that means is that like, let's say that I made this switch as a firing switch, and I didn't have the secondary push button, right? If you just had the 9 volt going through a light switch, okay, and you know, if this is sitting on the ground, if you hit your wire or something, like trip on it, and then it pulls this across the ground, and then, you know, that's firing. So you just merged yourself with heaven. That's what you just did. Notice that there's a black bar across there for the off position. That's because this is all white. You know, it's a residential standard light switch. You can't see it all the time. It's more indicative of the position if you just put some Sharpie marker across there. Black tape holds the whole unit together. If you ever see guys with equipment, combat engineers, EOD, stuff like that with black tape, I mean, this is your bread and butter for rigging up charges and you know, detonating equipment, breaching charges, all that stuff. It's going to use tons and tons of PVC black tape. We have the light switch. If we didn't have a secondary switch, it would just accidentally fire. It's way too simple. You don't want something like that. So you do a secondary switch. So the secondary switch is spring actuated. It's set up for being normally open. So when you press the button, it's going to close the circuit. So to fire, you know, you hook this up, flip the switch, turn, you just press that. So as soon as you press that, it fires. Alternatively, another, just to demonstrate, I mean, you could hold this, right? You could hold this down. It's hard to do with one hand. You could hold this down and then flip that up and it would fire, right? So if you wanted to, you could rig this up with you could tape down this button, and then you could rig up a tripwire on this, and then you could, flip that and have a tripwire actuated device, which would be illegal if it was explosive. You could do that with this setup. So this gives you some more flexibility. It's simple, right? I mean, it's just like a piece of trash. So what I'm modeling with this design is an M142 multi-firing device. It lets you do stuff like booby traps. So booby traps are illegal in the Army. We don't do them, but we do train them, right? So we have the 142, which is a very flexible system that you can do push, pull, lift, press, actuation of explosives. And this is it's got a lot of those functions, not all of them, but it's got a lot of them. So for instance, if you want to do a pressure release detonation, the way that you would do that for a booby trap, that would be like pressure release. That means that you have an explosive charge rigged to kill someone, and then next to it you have a victim actuated trigger where they're gonna pick an object up. They're gonna come over and pick this up, and it's gonna lift weight off, and then the charge goes off, right? As opposed to stepping on a charge like a landmine detonating, right? It's a different physical action that actuates the explosive. So anyway, if you wanted to rig that up, the way that you would do that is you can just pull this terminal off. This is the normally open terminal. You would put it onto the normally closed, right? You would put your weight on top of this, and you would tape this into the firing position. So this would be taped up. You would push this down, then you would hook it up to your charge, and then whatever the weight is that's pressing, the weight that you put down has to overcome the resistance on the spring. But you would put the weight on there, it's going to press it down, and then when the victim lifts this up, it's going to actuate, and it's going to, they're going to get BTFU. Just an example of, because it's kind of, why is all this stuff on here? It's because this is a multi-purpose firing device. So this is what I use along with the 22 AWG. I use this a lot for charge testing and just to have a flexible design that I can build in the field. So I can build this. I can build the same thing even without a voltage converter to boost it up. Like if that wasn't available, if there were no no internet or something like that, and SHTF or whatever, I could still, I can rig this up. So one of the shortcuts that I use that makes a big difference is, I use these WAGO connectors, right? You want to make sure that you get the one that is 24 AWG, because that's very small and it'll handle firing wires on your E-matches are going to be able to handle this, and then you'll be able to run. This is an 18 gauge wire that I use in the system inside, and then for my payout line, I'm using 22 AWG. So the way that these work is you just pop them open. Now it's open, there's a spring clamp inside of there, you stick your wire in there. The input line, put it into the WAGO with the logo on there or whatever, the black mark. That's where you put your input line. Your output line, you put that into the blank one. That just helps keep track of everything when you're moving really quick, setting up a ton of charges and things get confusing. This is like a simple indexing way to have management of your firing system so that it's more simple, and you have more reliability and you're less likely to fuck things up. But you're just gonna shove that wire in there, drop the clip. Now that's attached, and then you take your other one, open it up, and then you're gonna take your wire, drop it in there, and then it's connected. Now your 22 AWG can be as long as you want. Like I said, out of a 40 volt signal, if you're boosting up, you're gonna be able to get somewhere around 2 kilometers pretty safely, probably a lot longer than that practically. So you can use a reel for lines like that. I don't have a reel out here to show you, unfortunately. If it's real shit, you want to spray paint, right, and camouflage it. They're usually like bright red or bright orange. You don't want to be doing that. You want to use a camouflage reel. Anyway, here's the other end. This is the output end of the firing wire. This is a standard E-match. It fires like minimally somewhere around 3 or 4 volts, and it's about 280 to 300 milliamps to get it to fire off. So you put your wire in, clamp. This is why you're using the 24 AWG WAGO connectors. Put it in, pop. Okay, now you've got your firing wire set, and you'll notice there's very little exposed copper wire sticking out. There is some, you could trim these to make it so you don't have any uninsulated wire exposed, but this is way better than like hand threading. It's also a lot faster. So this is way faster to set up in the field. for a charge. I've got the light switch in the off position, right? So this is going to act as the safety. So, you know, you throw this onto fire, and then you're going to have to press the spring-loaded button. And when I do, it's just going to go right away, right? I mean, it's just instantaneous firing of this thing, and this is the way that I do my electric systems. It works great. You know, you're really going to do yourself a favor implementing some of these tips and tricks that I use. And so I think that's a general lab layout. I mean, there's a lot of different things that you could, you know, I mean, there's lots of things that aren't covered here. You should have a paper towel station, right? Like paper towels are huge. I guess we should say that, right? I keep glasses, gloves, all that stuff in the same section. So all of my PPE is in one area. So that's the general setup that I use. You can use that. You can use something else. You can borrow pieces from it, whatever. I don't care. I don't care if you subscribe. I don't care if you like these videos. I don't care if you even watch these videos. I don't care. Here's what you can do. What you can do is you can take a step back, and then
Kiss
your own face.